In this tutorial I will show you a few more things about the CLEM laboratories. Let's enter a laboratory. We're in the Coventry University Station laboratory, which we'd booked previously. Now this laboratory is based around an Arduino microcontroller, and we have three devices attached: an LED, a DC motor and a stepper motor. And when you're inside this laboratory, you can try any of the programs that are to do with those three devices, for instance the blinking LED, the DC motor or the stepper motor test. Let's try the blinking LED first. So within this program we have the code that will make the LED switch on and off. So we have the setup where we initialize the digital pin as an output. So we say pin mode LED is output, and previously we've said that LED equals 13. So that means that pin number 13 is set up for output. And then we have our infinite loop, and here we send a high signal to the LED and delay for 1000 milliseconds. Then we send a low signal to the LED and delay for 1000 milliseconds. So this has the effect of turning the light on and off for a second each time. Let's upload and see. And now we see the light coming on and off for 1 second at a time. When we want that program to stop, we can reset the board. Now let's have a look at another program. Let's have a look at the program for the DC motor test. For this program we have to include a library of routines from Arduino that gives the facilities for controlling the motor. Then we have to declare our DC motor, and we call it motor, and the 1 there says that it's on channel 1. So that means that the signals will be sent through the right channel on the Arduino board to reach the device. We set up a serial stream here so that information can be sent about what's happening in the program to a serial output. And here we set the speed of the motor, and we set the motor to be idle. That's what motor.run release means. That's our setup. And then within our loop, what we actually do in this program is get the motor to run forward for a while with the speed increasing in a loop, and then the speed decreasing. And then we get the motor to run backward again with the speed increasing and then decreasing. And finally, after that, we let the motor run on idle for a second. So let's upload and see that program. And here we see the DC motor running forward and backward. Tick tock. We might wish to reset that program now. Let's reset the board. And now let's have a look at the program for the stepper motor. So here again we have a suitable library. And we declare our stepper motor, AF stepper, give it the name motor, and this means that it has 48 steps and it's on channel 2. Again, we've set up a serial stream for informative output, and we set the motor speed to 10 revs per minute. And now we can tell the motor to move in steps. So we're telling the motor in this loop to move, for instance, 100 single steps forward and then 100 single steps backward. And then we're telling it to move 100 double steps forward and 100 double steps backwards, and so on. Let's upload the program and see it run. So we can see the stepper motor moving forward and backward. These are the single steps. And now the double steps. So if we want to stop that program, we can reset. So this tutorial has shown you 3 programs from the Coventry University station. You can run these programs and you can alter the programs to make the devices do different things. In the next tutorial, we'll look more at altering programs and storing programs for later reuse.